Yes, sir.
Okay. So let's wait for 1 minute and then we'll start. Okay, so let's start. So as I was discussing yesterday, let me just remind you of it, and then we'll try to basically connect it with something which we are doing in the class. Okay, so let's start with something which we were discussing in our last class session, which was we got ourselves into understanding one of the most simplistic and most used mathematical modeling approach, which was the empirical modeling approach. Okay, we realized that this lies in the bottom of in terms of the complexity of the mathematical models. So we can develop empirical models where we are just interested in developing some kind of a pattern between the data. So, I mean, the reason I started with empirical modeling, not with the sophisticated models in the start, was that, I mean, if you start with the simplistic things, then you can gradually introduce the complication into your understanding. Similarly, I mean, this is something which you should always remember. Personally, I felt I couldn't understand it when I started doing computational simulation. Was that I generally there is a tendency to introduce all kind of complications in parallel and then hope that it will work, but it will make you more confused about the whole process. So when you are developing a mathematical model for any process or any phenomena, it's always advisable to start with simplistic models and then gradually introduce the uh, complications. And when I was saying that this empirical modeling based approach is the most simplistic approach, what do I meant by that? So let's step back a bit, and I'd like to discuss with you something which you are usually taught in management sciences, which is called the uh, Maslow's. Has anyone heard this term, Maslow's pyramid or Maslow's hierarchy of needs? Anyone? Have anyone have heard this term? Yes, no.
No, sir.
Okay. So basically, I am teaching you something which you will be taught in maybe in the later part of your course. Okay. So this is something which is very common to any human being, and why I'm talking to you about this, because we will develop a analogous pyramid for our mathematical models. Okay, so that's why I am talking about this Maslow pyramid initially. Okay, so let me draw a pyramid, two-dimensional representation of a pyramid, which is a triangle, and let me divide it into certain parts, and then we will talk. The last part is more. Anyway, you understand what I'm trying to do. The idea is that since we are talking about something how human needs, how the hierarchy of human needs changes. Okay, so can anyone tell me what is the most basic human need?
Food.
So water,
Food, water.
Air,
What else?
air,
Say
Connectivity,
sunlight.
sunrise. What else? Okay, so what you are basically hinting upon is the physiological needs. So those are the most basic human need. You need that to survive. If you don't get water for a few days, the person might not uh, survive. Food is the similar thing. Sleep is a similar thing, and so on. This is a basic need which you need to provide. Someone said sunrise. Of course, you need to see sunrise. You need to get vitamin D. But I know a lot of students who have never seen sunrise in years. So I'm not sure whether, of course, that's the need. You need vitamin D, but I don't know how they are surviving. Anyway, the point is there are physiological needs which you need to have. And the idea of this pyramid is that your expectation, basically expectation increases in a hierarchical manner. So it's like, I can give you a very basic example. If you are going in a crowded train, okay, so if three people are supposed to sit over there, the fourth person appears from nowhere, and that fourth person says, I need to sit there. And requested those three people to let just allow that person to sit. And that person makes an excuse, okay, just give me this much space. I will just sit on that side. Don't worry about it. I'll not take your space. The moment you provide that much space, and if the journey is long, the person starts to gradually get comfortable, and it might so happen that the fourth person might be on top of these three people. So this is what happened in train. So this is how the human need or the expectation of humans basically changes, and that's very much natural. So if I plot the expectation, and I mean, when I'm not plotting, I'm just representing that expectation is gradually increasing as the needs are fulfilled. So first need is obviously the physiological. The next need, once the physiological needs are fulfilled, people look for safety. So, humans, when they started to basically form certain kind of society, they once they could fulfill their physiological need, the next thing which they realize that okay, we cannot sleep in jungle like that. We need to have some safety. We need to get into cave, or we need to climb on tree. I don't know, whatever. And this is how, and that survival skill still remains in human expectation. So the moment your physiological needs are fulfilled, you then look for safety, obviously for your life. The next part, once you are safe as an entity, you look for something which is called belonging, or sometimes people also call it love or warmth around the society they are in. So in this third rank of this hierarchy, you are basically looking for certain kind of belonging in the system you are functioning. So this is the first time you're talking about certain kind of society being forming out of these individuals. So far up to this level, you're just talking about the individuals. So let me write it. So you in up to this part is it's generally the individual instincts are critical. In this part, it's the individual instincts are critical, and beyond this, certain kind of a collective behavior is evolving. Okay, so beyond this, there is some kind of collective behavior is arising in the human system. Once you have this belonging in that collective system or collective society, the next need is esteem, इज्जत, इज्जत चाहिए. Whatever may happen, you need esteem. You want to be something of part of that collective system. Okay. I do not know how many of you have seen that. I mean, stand up of Zafir Khan, where he talks about Ijjat. So you should watch that. That's a very funny video. The point is that as you are moving along, your need I mean, and it's what I should say. Its features are changing. It's becoming more and more broad, if I may say. I mean, if you talk of from the physiological needs to the esteem, I mean, there is no direct one-to-one correspondence between these on surface. But as you are moving hierarchically in this kind of need, you are moving gradually. And obviously, in the last, you have self-actualization. So all that spirituality and all that things comes up. So why am I basically talking about this? Maybe you will be taught about this. You are going to be taught about this in your management sciences or whatever different kind of subjects. But we are talking about this because we would like to have an analogous pyramid for mathematical models. Okay, so we can have an analogous pyramid for mathematical models. Let me just, I mean, okay. So now let's talk about something which concern us. Okay, so let's talk about an analogous. Sorry. Analogous hierarchy of mathematical models. Okay, so as I just mentioned, I mean, I have there is a reason I have kept it in parallel. When you are only interested in developing very basic model for any complex process, when you are trying to develop interrelationship between just variables which you are seeing, you just have, say, some data points, input, black box, which is the process, and the output. In that case, and you have no understanding how these input variables are interrelated. Okay, so this is something which we discussed in the last class. So we were talking about some input which is going in my process and it is giving me some, okay, some output. Okay, this is what is we are talking about. Okay, so in very simplistic case, you can go on and do sensitivity analysis and all those kind of things. But in a very simplistic case, you're just looking at these individual parameters. So if you look at the parallel in the Maslow pyramid, where the individual's dynamic was critical, even in our hierarchy of mathematical model, generally, in this case, we are talking about these so-called empirical models. Simple case, no interactions are being studied. I mean, no high-level interactions are being studied. It's just we have some data, or we are doing some experiments in generating a data and trying to understand how the system is behaving, without putting much effort into what really is going on at the fundamental level. So that's a very critical part. That's why I was telling that these empirical models are a very simplistic model for dealing with a very complex phenomenon. And these are the most, I mean, uh, primitive, and they're lying at a lower lying level in the hierarchy of models. That's why I wanted to present this. So once you have developed the empirical models and you are interested and you are ambitious to develop much more fundamental understanding about things which are going around you, now if instead of these individual variables which are going inside this black box or this box in which you do not know what is going on, now suppose you develop much more deeper understanding about this box. So you divide this box into many more boxes. I mean, all of this is being an abstract understanding. You still do not know what is happening, but from your empirical model or your experience, you have an understanding that there are some unique phenomena which is taking place, or there are sub processes in the processes. So these are basically sub processes inside a process. There can be a big process and there are sub processes. I can give you an example. Suppose there is a human body. Now, in a human body, I can have a heart doing a circulation part. My brain is involved in a neural kind of function. There are individual parts. So you, even though you do not understand the whole physiology of the human body, you can basically have an understanding that there are subparts in the body which are basically giving me the ultimate output, which is the functioning of the body. Another example I can give you in the context of I mean materials in a particular application. Now, if you have a material acting in a particular application, suppose you have a steel which is in a structural application in the say seashore kind of situation. Now, if you are using a particular steel for any structural application at a seashore, if it would have been in a vacuum condition, then corrosion might not be a critical issue. But if that structural material is in the at a sea near the seashore, then the corrosion is one factor. In addition to corrosion, its structural property is another factor. So you can have sub models for corrosion, and there can be another model for the structural or the strength of the material, and they might be interacting with each other. So the point is that all of these models can have interrelationship with each other. Okay. And again, these interrelationships are empirical in nature. You can develop earlier you were just developing empirical understanding about the variables with certain output variable. Now you are developing an interrelationship which is again empirical in nature between various parts of your model, and such again you are not getting into the fundamental of things, that how exactly things are happening. Okay, and we will talk about this in detail in the later part, but I just like to mention that these kind of models are called phenomenological models. Okay. And obviously, if you now instead of black box, if you develop much more deeper understanding about how exactly things are going on, what is causing what, okay, if you have a bit of understanding of that part, then you are developing a yet more sophisticated model, which is called the mechanistic model. Okay. So I'm not talking much about mechanistic model at this stage, because what mechanistic model is basically telling that in all of these individual boxes, now you exactly know that how the behavior of that system is being guided. Okay, so I'm just thinking about example from the material science. So suppose you're talking about we're just talking about a steel which is in the seashore application. close to C, it is in structural application. And we just discussed that we can develop a phenomenological model for, say, corrosion, because corrosion is going to be a critical issue there. But it needs to also have a strength. What is the strength of that material depending upon the various features of that material. Now, when we are talking about these two submodels, we are talking about these two submodels. So I'm talking about one submodel, say, which is talking about corrosion, and there is another submodel which is talking about the strength of that material. There can be range of input variables, and this goes inside my uh, main process, and I have one output which is basically the performance of that material. Okay, so this is how things are going. This was my phenomenological model initially. Okay, if it would have been an empirical model, then this green boxes would have been missing. I mean, I have no idea that what are the sub processes which might be happening. But in my phenomenological model, I have an understanding of sub processes which might be going on there. In mechanistic model, now you go deeper and you see what is the mechanism which is influencing the strength. So now I am trying to develop an understanding that what are the various variables which is influencing the strength. Now the strength can be influenced by the grain size. It can be influenced by the dislocation density. It can be influenced by, obviously, much more fundamental feature is the crystal structure of the material, and so on. Now, if I have these models which encompasses all these variables in a mechanistic way, where it provides me exactly what is happening, then such models are basically called the mechanistic models, which basically sits on top of it. Because these are, sometimes people tend to use the word like physics-based models. So their exact physics of the process is now being understood. So suppose when you're talking about the strength, now the strength of the material can be understood in terms of the resistance of the dislocation motion through the crystal. Okay, so that kind of understanding, if you are developing, then you are gradually developing mechanistic kind of model. That okay, the dislocation movement is difficult. Why it is difficult? Because the barrier for the dislocation movement as it is moving on the slip plane is getting fluctuated by so and so. So you are basically developing all kind of quantitative approach to basically predict the property of the material. Okay, and on top, obviously, you can have these so-called predictive models. When I'm saying predictive models, I'm using this term in a very vague manner. I mean, someone can call empirical model to be a predictive model. But when I am saying that you want to develop predictive models, what I mean by that you can use any of these empirical models, phenomenological model, mechanistic model, depending upon your need to develop a holistic understanding about the full system. So you can have a predictive model for, say, a material in a particular application. I gave you a few examples, such as suppose you want to use a material in a fusion reactor. If you want to use a material in a fusion reactor, then you need to have a model which can predict the lifetime of that particular material in a particular challenging situation, which is you have energetic ions, you have all kind of corrosive environment your material is in. So in that case, in this predictive model, you can have various models for various situations. So suppose you can have empirical model for some part of this application. Say, I mean, suppose you are talking about neutron is coming and it is basically knocking off in an atom. and when it knocks off an atom, it creates a vacancy. So that's one phenomena. Now, another phenomena is when these vacancies are being created, they would like to move. Okay, so that is phenomena number two. Phenomena number three is how the vacancy comes together and ultimately creates the void. Phenomena number three. Another thing is when this incident neutrons are coming, they are basically increasing the local temperature in the material. So all, I mean, what I'm basically trying to present to you over here is any challenging material application you might be studying, you can basically divide it into various sub processes which might be taking place, and in for those sub processes, depending upon the requirement, for some part you can develop the empirical model, for some part you can develop the phenomenological model, and in certain part you can develop the mechanistic model depending upon the pragmatic issues. So suppose in ideal world you would like to develop the mechanistic model for everything, but in certain cases it is simply not possible, so you have to go for some other approaches uh, as a way to basically deal with that kind of scenario. So obviously the precision is increasing in this side, but being an engineer, materials engineer or a scientist, you will develop a holistic model which contains many models inside to predict a property of a particular material. And this is why these predictive models sit on the top, because they encompasses everything. Okay, so before I go further, do we have any question on this part? No question? Okay, if there are no question, then we will go back to our original discussion which were having yesterday, because we are basically studying at this stage these so-called empirical models, and the aim of the last class was that if we have some data with where there is one independent variable which was the grain size, and there is a dependent variable which is the strength. So just by looking at the data, can we develop some understanding or not? So to carry out this analysis, we defined a workflow which is very common to all of the activities you tend to do in this kind of analysis. That you will read the data, you will store the data, you will carry out the analysis maybe, and then you will deduce something out of that data. And we are doing this in the umbrella of developing an empirical understanding about this grain size. And I mentioned to you that you have to play with the data to see what is the relationship between strength and the grain size. What is that d, how the d, if there can be any what is the power of d which is influencing the strength basically. Okay, so this is something which we had discussed yesterday. Now, I'll ask you guys one by one, very fast, so that I can see what you have done. Okay, so let me ask, and you have to share your screen and show me what you have done. Okay, so now let me call by one. Orgio, can you share your screen and show me what you have done?
Sir, can you give me 1 minute? I need to log in from my laptop. 1 minute just.
Okay, so we will move to the next person. Shubhumay Gupta.
Yes, sir. Just a second. Sir, can you see my screen?
Not yet. No, yeah, I can see now.
Okay, sir. Just a second.
Yeah.
This is the strength versus grain size graph. And
Mm-hmm.
this is, I mean, I found out that it is proportional to d to the power of minus 0.5 after doing a few, I mean, uh, few random guesses actually.
Okay, so show me what those random guesses were.
Actually, sir, to be quite honest, I tried to see what kind of graph it was in Excel. Then I found out it was an exponential graph, and then I did some trials with the powers.
Okay, but
Okay,
the
sir.
point idea is I understand, but the idea is you see I understand that you did that in Excel and you just were looking into various things. But the idea is I know you can use Excel and Excel is a very good platform to have an understanding. But try to use this platform. If you could have shown me over here, then it would have been perfect. Anyway, but this is a good attempt. So you can stop sharing your screen and we will move to the next. Okay.
Okay,
Sir,
sir.
can I show you now?
Yeah,
Roll
please go
number
ahead.
two, sir. Okay, sir.
Just a second, sir.
Yeah. Shubham, Shubham, share your screen.
Sir, I've stopped sharing, I think.
Yeah, yeah, yeah. No, no, but you are again sharing, I guess. So stop sharing. Shubham need to share the screen.
So it's me, Orgo.
Okay, Orgo, you're. Oh, Shubham shared earlier. Okay, Orgo, please go ahead.
Yes, sir. Sir, I couldn't complete means the next relationship part, but the first part I did.
Yeah.
I imported the data. I read that data, and after
Mm-hmm.
that I made the strength versus diameter graph. But I couldn't find the relation. Means how to find the relationship. That part I couldn't figure out.
Okay, no
So
problem.
I
No.
completed up to this
Yes,
much.
sir. That thing I also wanted to say. I couldn't
Means if
couldn't
there is
find the.
any command that can help us to find that correlation, we I don't know about that part. So I
Yes,
completed up
sir.
to
To
this
find
much
that
only.
particular equation.
Don't worry about that part. That's the thing I want
Yes,
to
sir.
see how you are moving towards the solution. That's the say you have done one thing. I mean, Shuma, where you got into Excel and you tried to do something. Don't worry about that part. The thing which I'm seeing is not everything when you are doing. Okay, I'll come back to that thing. Don't worry about that part. So good. Argo, you can stop sharing your screen. We can move to the next person. Stranger. Yeah, yeah. So you also did the reading of the data. So you plotted that. Why you did manually? You see, yeah, okay. This is a very critical part. I know there are just 6 data points, so you could type it in. But the important part is you should automate that process. So you should read the data. Mhm. No worries about that part, but the point is you should automate that process. Fine, you have done something. So the feedback is you uh, when you read the data, you should automate that process because you can have a million data points in certain cases. So sorry, what I'm telling you that you have to I mean, you have to read the data in a way so you're not copying the data, you're not manually putting in the data. That's what I'm trying to mention, which you have done. Okay, number. Yeah. No, that's fine. That's fine. I can see that. That's fine. So you can stop sharing your screen.
Oh,
Sure, sir. So, is my screen visible?
Yeah.
So I imported the files that you uploaded in the classroom.
Hmm.
Then I used three libraries, pandas, numpy, and matplotlib. I defined the data frame, uh, gave the columns as grain size and strength title. Then I defined the chromium one and the nickel one differently. I plotted the graphs with a scatter plot as the points were highly differentiated. The difference between the points were very much so. I used the scatter plot rather than the plot. And for the equation, I could use that in the Excel and get the equation from the best fit line.
What was the question? So what was the equation? You said you use Excel, isn't it?
So I didn't do it. I didn't do it, but there's a way that you can do it. Just you have to plot the graph in the Excel, and you can get the equation from the
Okay.
labels part. So I didn't do
Okay.
it yet. No.
Okay. So you can stop sharing. Uh, Amit, sorry, Deboshmita, you can.
Yes, sir.
Varnit, you can mute yourself. Yeah, that's fine. You have read the data. Okay, you have read the data and fine. Uh, okay, what else you have done?
Yes, sir. I cannot get you because I was just adjusting the sound over here due to the echoing. Can you please
No,
repeat it?
that's fine. You have read the data, and now how do you approach this problem to see what's the functional relationship between the data set? That is the independent variable and the dependent variable. How did
So
you?
created this um, matplotlib dot py py
Uh-huh.
plot as plt and import numpy as num, and then data here I just use this num over here and I call the function here.
No, no, Devasmita, I can see that. The point I am asking you is there was a part where we have to see how the X and Y are related to each other. So, what is your approach? What were you thinking? That's what I want to know.
Um, X and Y. So
Going ahead.
actually, yes, sir. I took two arrays X and Y. X as for this for the rows and Y for the columns. So here I just printed them. I collected the data X in these two array I and J in the data,
No,
and then I
no, Devasmita, don't I understand. I can see that straight away. What question I'm asking you straight forward way is don't worry if you don't know the answer. The point is,
actually
uh,
yes, I don't know this language first of all, and my friends
no, no,
actually
fine.
helped
That's why
with
it's
this
commendable
plot.
you have done. I mean, I'm not talking anything about it. I'm just asking you what you are thinking and what is your approach to find relationship between strength and the diameter. Can you go in the end? What else you have done? Just scroll so I can see what. Okay, you have done till this part. That's fine. So think about that part. You have an x value and you have a y value. Okay, y is varying in certain manner. It is decreasing in certain manner.
Yes, sir.
So obviously, the strength is inversely related to the x value or
Yes,
the diameter value.
yes, sir.
But
X
what
is
is the power of that x? That is something which you need to think. Okay.
okay, sir.
Okay.
So it's something to the power. We can find out from this hit and trial by
Yeah, you
um.
can do that. Some people are using Excel, but I'm leaving up to you guys that how, I mean it's an open thing how you basically try to find it out.
Okay, sir.
Okay. So stop
Okay, sir.
sharing and we will move to Amit. Okay.
Good morning, sir. Sir, I did till this.
Okay. Okay. I understand what you have done. Go straight to that question. What is your approach for strength diameter interrelationship?
Sir, it is inversely related, sir.
But what is the power? How do you find it?
Sir, that I couldn't calculate, sir.
Okay, fine, fine. Think about it.
Yes, sir.
Priyanshu, share your screen. You need to do it fast.
Yes, sir.
Stop sharing, Amit. Share your screen.
Sir, sir,
Yeah.
is my screen visible?
Yes.
Yes, sir. That is
Okay.
that's I'm only plot the graph by manually inputting the data.
So you don't need to manually input it. You have to find a way to how to read it in automated manner. First feedback,
Yes, sir.
and second is think about how this interrelationship is working. Okay.
Okay, sir. I will try later.
Okay. Stop sharing, Somnath.
Yes, sir. Good morning, sir.
Good morning.
Sir, is my screen visible?
Yeah.
So here I have done it. Sir, I couldn't derive a way to sir find the correlation.
I
Actually, I
can't
have done
see.
till
I
plotting
can't
the
see your
graph.
Jupyter notebook. I can't see it. You have to click on it, that maybe.
No, no, sir. I am showing it in my Visual Studio only. So is it not visible?
No.
So, sir, just a second, sir.
Everyone be ready with everything because we have to do it fast. So uh,
Sir, is it visible now?
no, no, no. I
Sir,
think
I
you have.
don't know sir, why it is happening, sir.
No, no. Okay, let's wait for just come later. We will move to the next person.
Okay,
This
sir.
with us.
Okay, sir.
Back to you. You check what the issue. You try to share the Visual Studio windows only, and then okay. Pritam, share your screen. Pritam is not here. Okay, absent. Uh, Chandrabhushan.
Yes, sir, I am saying.
Okay, so you have read the,
Sir,
again you have manually inputted things which is not right. Go in the end. So, okay, so you have not done that, the relationship part. Okay, fine, fine.
sir, we can do it like manually to like we can do it in pieces. There are straight lines and with the slopes and using our differentiation and
No, 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 no. That's not, yeah, I mean, you're thinking in that way that, okay, that's how this is
we
varying,
can
but
find the we can find the equation of the straight lines pieces by pieces like
why will you do that?
I can think like it if we do it in pieces we may find
Okay.
like
I mean, I cannot understand why will you like to do that, but I'd like to see what you do with that. Okay. Okay.
Okay, sir.
Whatever you feel like, that's open end. It's up to you. How you want to approach this problem. It's up to you. Okay, Shubham. Yeah, it's visible. Straight
Yes,
go.
sir. So, sir,